Hey everyone, I've got an old-fashioned toy here called a Twirly Whirly. It's really just a couple pieces of cardboard, some tape, and a string. The idea is that you can wind it up and then pull rhythmically on the strings to kind of get it to wind and unwind itself. And it's a little bit challenging to get going, but once you get it going, it goes on its own and it's easy to keep going. Now I got to thinking, what happens if I can change the geometry of a Twirly Whirly? So I 3D printed 3 of them that have the same mass. This one is a disc, and if I spin it up, you can see it's not too hard to get going, and once it gets going, it's pretty easy to keep going. Now this one is a ring, and it's a little bit more challenging to get wound up and get going. But once you get it going, it really wants to go. It wants to keep going, and it's easy to keep spinning. Now this last one is just a rod, and it's going to have, again, a different moment of inertia. And it is really hard to get started. And then just about impossible to keep going. And so the idea behind these would be to give them out to my students and then have them experience moment of inertia and kind of then be able to talk about what is this thing, why is it that the disc is so much easier to keep spinning than the rod. And I also have another one that's also a disc, so I have this disc and a very different mass because this one's made out of wood, this one's 3D printed and mostly empty. This one has probably the highest overall moment of inertia of all of these, and you can see that as it spins, and it really wants to rewind itself every time. Again, the whole point of these would be to give them to my students, let them play with them, and then we talk about why each one behaves the way it does. Thanks.